Okay, this is going to be a quick video on section 6-4. And in section 6-4, we were labeling and classifying our special systems. And this is the half sheet of paper that I had given you. Um, Up until now, we had really been focusing just on consistent and independent um, systems. And those are your typical system that when you graph each line, you're given one intersection point. And so there's really only one solution. However, today we're going to dive into our special systems. Our special systems are going to be the ones that are consistent and dependent, and those are going to be the lines that are actually the exact same, and they're one on top of each other, and so they have an infinite number of solutions or intersection points. And they're also going to be the ones that come out to be true. And then our inconsistent system, it's going to be the systems where the lines are actually parallel. So we're really going to have no solution because remember, a solution for these systems of linear equations is where they intersect. Since they're parallel, they will never intersect, and they're going to be when they come out to be false. So let's look at an example and see if we can make some sense of this. Okay, here's the first example that we're going to do. Um, what we need to do is first, we're trying to solve this system and see what kind of solution we get. And again, we're either going to get a solution that has one exact point, or one that has an infinite number of points and comes out to be true in the end, or one that has no points and comes out to be false. Okay, looking at this, um, we need to find a way to solve this. There are three different methods we can either do by graphing, by substitution, or by elimination. Because one of the uh, equations is in slope-intercept form and the other is not, substitution is typically your best bet. We know that it's y equals something, so we're going to take that and plug it in wherever we see a y in our second equation. So we write out our second equation, minus 1y plus 1 equals 0. So notice I rewrote this entire equation, and wherever I see the y, I'm going to delete that, and I'm going to insert what I know y is, which is 2x plus 1. Now the tricky part about this is the negative 1 times that entire quantity, so we need to distribute that out. And you should get negative 2x minus 1 plus 1, and then bring your 2x down. This is what makes this system special, because when we take 2x minus 2x, it actually cancels out and we get 0. When you take negative 1 plus 1, we actually get 0 again, and so when it simplifies down, we actually get 0 equals 0, which we would agree is true. This is, again, what makes this a special system. Okay? Before today, when we solved these, it always came down to be like x equals something or y equals something. Not in this one, because the x is actually canceled out. But this true statement helps us identify which one, which type or classification this system is going to be. Because it's true, we know it's going to be consistent and dependent. And you know that by looking at this chart that I gave you. Because it was true, we know that it's consistent and dependent. We also know that if we were to graph both of those lines, that they'd have an infinite number of solutions, and the lines are actually turn out to be the exact same, and they would line up one on top of the other. So again, we're going to write consistent and dependent, because that's what kind of a system this is. Okay, let's try another example. For this example, we have a system where it's negative 1 half x plus y, so this is in standard form. This one is not in standard form, it's not in slope-intercept form, but it is pretty close to standard form. If I simply move this one over, we'll be there. So I'm going to do that by subtracting, so you'd get negative x plus 2y equals 2, and then this one would stay the same. And that allows us now to use the elimination method. And that I highly recommend doing that. So if we want, we can try to figure out they're not going to naturally eliminate, but if I multiply this bottom one by negative 2, we'll see that these will eliminate. So remember, this goes to everything. So the top equation stays the same. And the bottom equation, negative 2 times negative 1/2 is 1x. Negative 2 times 2y is negative 2y. And that will equal negative 2. And again, you should be seeing why this system is special. Normally, when we go through these systems, we would come out and get something like x equals a number or y equals a number. In this one, we're going to see negative x plus positive x cancels out. 2 plus negative 2 cancels out, so we're left with nothing over here. If you look on the other side, the 2 and the negative 2 also cancel out. We're left with nothing over there, which is also a true statement. Because it's a true statement, we know that this is a consistent and dependent system. Let's try another one. Okay, this one, both of them are solved for y, so I would use the substitution method. We're going to take what we know y is and plug it into the bottom one. So since it was y equals x plus 1, we're going to delete the y and put in 2x minus 1. First we need to distribute, and you get 2x minus 2 equals x plus 1. We're going to add 3 to both sides. Or excuse me, add 2 to both sides. I misread my handwriting. And we're going to get 3 over here and 2x over here. Subtract x. We're left with x equals 3. So since we got x equals 3, we know that this is not a special system, that this is a consistent and independent system. It is the one that we've been working on up until this point. I want to take it, go ahead and finish it so that we find out our exact intersection point. So we're going to take this x equals 3 and plug it in here, and so you get y equals 3 plus 1, so y will equal 4. So our solution would be 3, 4. Okay? So not every one of them are going to be special, but the ones we still have a classification for them no matter what. This was our solving special systems. If you didn't get the homework done, here it was. I had some other examples, but I think you should be able to get it from this. If not, come find me and we can do some extra problems. Good luck.